This final lesson on scientific notation is going to show us how to multiply two numbers in scientific notation. Now, the idea here is actually combining regular multiplication with our exponent rules from earlier in this section, and then making sure our answers are actually in scientific notation. So let me show you something. Technically speaking, we can use just expanded multiplication to write this down. And then multiplication is commutative, so I can rearrange it to put the 3.5 next to the 3 and the 2 10 to the seconds next to each other. Now 3.5 times 3. 3 times 5 is 15, carry the 1. 3 times 3 is 9, with the extra 1 is 10. 1 decimal place. 10 to the second times 10 to the second is 10 to the 2 plus 2. Remember that rule from earlier. Same base, 10. I can write it as a single thing by combining its exponents, so that's 10 to the 4th power. Now, we've actually done the multiplication. We have 10.5 times 10 to the 4th power. The question is that a scientific notation number? If it is, we're done. If it isn't, we got a little bit of work to do. And unfortunately, it's not. On the left side of the decimal point is a 1 and a 0. If the 0 were on the other side of the 1, it wouldn't matter. But it's between the 1 and the decimal point, meaning we have two important digits to the left of the decimal point, and we're not allowed to have that. So how do we fix this and get this in scientific notation? I think the easiest way is just to do what this says. So 10.5 times 10 to the 4th says take that decimal point and move it right 4 times. If you do that, you wind up with 105,000. And now to look at this and say, okay, my decimal point is here in this normal number. I need it to be over here between the 1 and the 5. So I'm going to have 1.05. I do not now need those extra 3 zeros. Times 10 to the what power? Well, how many places did we move the decimal point? 5. I think this is the easiest way right now for you to take something that looks like scientific notation but isn't quite right and change it into proper scientific notation. Write it out, expand it into a normal number, and then say, okay, this normal number can be written in scientific notation, but the decimal point needs to be in this different place than it originally landed. Now, for the remainder of the problems, I'm not going to expand them and write them out the way I did in 65. For 66, I'm just going to say, okay, we need to do 3.9 times 4.5. So we're going to do that. 5 times 9 is 45, carry the 4. 5 times 3 is 15, with the extra 4 is 19. Start our second line with a 0. 4 times 9 is 36, carry a 3. 4 times 3 is 12, with the extra 3 is 15. Put those together. We're going to get 5, we're going to get 15, so we carry a 1. We're going to get 7, we're going to get 1. 2 decimal places means 2 decimal places in our answer. And then our tens. So we have 10 to the 1, and we have 10 to the negative 1. So 1 plus negative 1 gives us 10 to the 0. Yes, you can have scientific notation with 10 to a 0. But this ain't it. Why? Because to the left of our decimal point, we have 1 and 7. So, write it as a normal number. Well, what does the exponent of 0 and 10 mean? It means the normal number is 17.55. But the directions stipulate our answer must be in scientific notation. which means our decimal point needs to come back one spot and be between the 1 and the 7. So we get 1.755 times 10 to the first power. I invite you to pause and try 67 and 68. Number 67, we have 2.6 times 3. So 3 times 6 is 18, carry the 1. 3 times 2 is 6, plus 1 is 7. 1 decimal place. Hey, 7.8 is great. That means this will be our final answer. For our tens, we have 0 and we have negative 1. So we have 7.8 times 10 to the negative 1. And yes, scientific notation, negative exponents are fine in scientific notation. I don't have to rewrite this as like 7.8 times 1 over 10. Finally, in 68, we're going to have 8. Actually, let me do this the other way around. It'll be a little bit shorter. 3.06 times 8.2. So 2 times 6 is 12. Carry the 1. Just have the 1 now. 3 times 2 is 6. Start with a 0. 8 times 6 is 48. Carry the 4. But that means the 4 is right there. 8 times 3 is 24. Do our addition. 2, 9, 10. Carry the 1. 5, 2. 1, 2, 3 decimal places. Sad face. Only sad face because 2 and 5 on the left means we're going to have to do some adjustment here. Tens, we have 10 to the negative 2 and 10 to the negative 2, so we have 10 to the negative 4 when we combine the exponents. Write this thing normally, so let's see. Decimal point has to move left 4 times. Now I know I'm not showing the work on me doing that. I think you can do that yourself after yesterday's video. You don't need to see me do it. Decimal point truly needs to be between the first 2 and the 5, so that our final answer, see if I can squeeze it in here, is 2.5092 times 10 to the negative, and let's see, we would have had to have moved our decimal 1, 2, 3 places to get it where it needed to be. Final answer, 2.5092 times 10 to the negative third power.